Hello guys, my name is Tomek. I work for Parity Technologies, as you can see, as a core developer. And I'm going to talk about off-chain workers. There is no fancy subtitle, unfortunately. So if we talk about off-chain applications, this is usually what we mean right now. So it's an application that is running separately from the blockchain client, whatever that blockchain client might be. And that application is usually doing these 4 steps. Some of them are obviously optional. And yeah, this is what usually happens. So over the RPC that is exposed by a blockchain client, you want to retrieve some data that is then being transferred to this off-chain application. That application has its own database, its own storage. It is able to do some external calls, for instance, HTTP calls. It may do some processing of the data that it extracted from the node. And then at the very end, we want to feed back the result on-chain. So we want to create a transaction that ends up being included in the chain. And this is the result of this computation and processing that we have done. Some examples of these off-chain applications that we see nowadays are listed over here. For instance, you might want to fetch the BTC to USD price and feed that back on-chain as a price oracle. Or any other real-world data that you can find on the internet, you want some mechanism to actually feed that back on-chain. Another use case might be some heavy computation. So doing any on-chain processing is very expensive. You don't really want to do any hard computations during block import because it's going to be done by every node in the network, and obviously the block processing time is limited. So we want to keep the block processing time as small as possible, but still at the same time we have a couple of use cases where heavy computation might be necessary. To just pick one example of this list, for instance, fragment. Computing fragment is an iterative process, so you can, if you spend more time on the computation, you might get better results for that. And any unbounded enumeration of the storage or any unbounded computation on the on-chain data would pretty much fit off-chain application better than on-chain. Another use case might be indexers. So you get some on-chain data, and then you extract some data of it, or you kind of compute some aggregate. You put it to the separate DB. Pretty much you don't need to feed back anything on-chain, but you still have this workflow of fetching and then processing. So what are off-chain workers? So we want to move from this model into this model. So we want to move the off-chain application inside the node. Because RPC is slow, because other reasons that I'm going to show on next slides, but because sometimes the state data is just too big to be transferred over RPC. Yeah, and and how does it work in practice? So what we want to do with the off-chain workers. So off-chain worker is just part of your runtime code. So whenever you're writing your runtime, you may write an off-chain worker at the same time. Because of that, it has direct access to the state. So you don't need to go, don't need to like take something from the database, then serialize it, send it over RPC in JSON format, deserialize on the other side, and then process it. You just directly go to the state and fetch whatever you need. So it's just a DB lookup. This is pretty important part. So whenever you upgrade your runtime, your off-chain worker is going to be upgraded again. And on the next slide, I will show the consequence of this as well. Since it's the runtime, it can work in standard environment. By standard, I mean native execution environment or in WebAssembly environment. So this is at the same time an advantage and disadvantage because an advantage is, yeah, if you upgrade your runtime, everyone has the correct version. But disadvantage is you can't really use all the standard libraries that are out there. But it doesn't have to. So if you are OK with your off-chain worker being only native execution, then you can just use standard libraries, and you can kind of opt out from this WASM execution. So why? Why would we do that? So it's easy to run an off-chain application if you are just a single person or a single entity running it and monitoring it. If you want to convince all the validators to run your off-chain application, for instance, to do this better fragment, then it gets like a little bit more complicated. You need to give them instructions how to run your off-chain application. They all need to do it. They all need to monitor that application. And it gets especially hard if you want to upgrade your runtime. If the format is changed or you have just found a bug in your off-chain application and you would like everyone to be running the newer version. So as you can see, these guys are not happy because they are not running the correct off-chain worker code. So for instance, they are missing some rewards from this scheme that you have set up. There is one thing that I would like to emphasize on that slide. Look at this guy over here. So that guy might be malicious. The fact that we have upgraded the runtime and the off-chain worker code, and we assume that everyone is running the new version of it, with off-chain workers, it's a little bit more tricky because this is not something that we get consensus over. These computations done off-chain are not part of the consensus, obviously. So you can't really tell if those guys are running the correct version of the code or not. They might be running some malicious version. We just make it easy for people to run the right version, but we don't protect from this malicious guy out there. So whenever you submit anything back on chain, you need to verify that whatever was computed correctly. Or you need some kind of game that is happening on chain that makes sure that the data is correct. So how does it work implementation-wise? So after every block is imported by the node is doing another call to the runtime, and it's trying to invoke the off-chain worker for that particular block. The off-chain worker for that particular block will have access to the state after the block was executed. If you are building your runtime based on frame, any pallet can declare an off-chain worker. Inside your declare module macro, you just put a function called off-chain worker, and then you can write your off-chain worker code. What happens under the hood? Whenever the node is calling into the runtime, it's calling actually to the executive, and then executive is dispatching these off-chain workers to particular modules in your runtime. So since off-chain workers are part of the runtime, and the runtime is running in the sandbox WASM environment, how come can we have a separate database or a separate, or make this external HTTP calls that we can do with off-chain applications? So off-chain workers are allowed to call an extended set of this SPIO APIs that we expose. And some of them include, for instance, calling HTTP service, getting local time or local randomness. So this is not something deterministic. This is something that's going to be different for every node running the off-chain worker. We also have access to local key store. So whenever there are some crypto keys on this particular node, we will be able to sign some stuff or to verify some statements. And there is also a special database that is available for off-chain workers where you can store some data. And obviously, it's not the state database that we use for on-chain stuff. This is something that's going to be local for the node, but can be used to store these large amounts of data, or for instance, to coordinate work between workers. Yeah, let me show you how it looks like in the code. So I have pretty much a node template with this example module, and inside this declare module macro, when I declare my module definition, I can just create a function called off-chain worker, and then I can do some stuff inside. So for instance, I'm like reading a storage here, so there is no special API for that. If you want to read on-chain data, you do it in the same way you do it for regular runtime modules. You can like print some warnings or log messages. I can also call into other modules. So I'm taking a block hash from the system module. Then I can call fetch BTC price. And it's going to look like this. And this fetch BTC price is actually doing an HTTP request with our custom HTTP wrappers. So there are two kinds of this HTTP API. There is like a very low-level API. You can stream a request, a body of the request to the server, and also stream the response back. And this is actually a high-level wrapper that makes it a little bit easy to call external HTTP servers. It's sort of based on request, this library for Rust, but it's like suited for this WASM execution as well. So I'm going to wait for this request to finish. Then I will check the response codes, and then I might do some parsing of the data that I receive. Then another function that I would like to show you is submit BTC price. So I have this special trait called submit transaction, and that allows me to feed back the BTC price on chain to create a transaction that is going to be later included by one of the validators. If you want to learn more about this, I'm going to be hosting a workshop at 4 p.m. today, so please join me. And future plans for off-chain workers are over here. So in a like mid to short term, I would like to parallelize the workers. So currently, every module can declare a worker, but they're going to be executed sequentially. So we want to make those modules run in parallel, even if they are for the same block. Doing this local database operations in off-chain workers is a little bit cumbersome currently. There is just low-level key value DB API, and it would be cool to have this collections API that we have for regular runtime, like declare storage stuff. Another thing is fork-aware local storage. So the off-chain workers are being executed for every block that is imported. It means that if there are forks in the network, you might have two off-chain workers running on the same height, on different blocks, but on the same height. This fork-aware database would make sure that whatever other worker is writing to this database is not visible to another worker on the same height. And some usability and developer experience improvements that are listed over here. There are some long-term plans as well. So currently, off-chain workers are executed, but only if you are fully synced. So the use cases that we wanted to tackle were the ones where you are already synced with the network and you just participate in some, and you fetch this current data. You don't care about whatever happened in the past. But we have identified some cases where actually running an off-chain workers during sync would be beneficial as well. Imagine this indexers. You want to create this local off-chain database, but you based it on every block that was imported because there's some information that you need from there. So that's going to be a plan for off-chain workers 2.0. And even longer future, it might be a good idea to detach those workers from block imports and instead make them like this long-running processes that pretty much run along the node and are allowed to receive and process some messages that happened in the system, some events. For instance, a block import is one of those events, and then this off-chain worker 3.0 would be able to, on every block import, to call this off-chain worker 2.0. Cool, and that would be pretty much it. So yeah, as I said, come to the workshop if you want to learn more. We are going to build an off-chain worker that is fetching a Bitcoin price from API and then feeding it back on chain. Thank you. I guess we still have some time for questions.
The question is about more node, full node. Like, what if you say that if WebAssembly, if off-chain workers will be in WebAssembly, there will no hacks like old versions of off-chain in the new version of network. But what about node? If I will change some logic, I will do some break changes to node. For example, change RPC. Should I update my nodes on the whole network?
So you mean, yes, if you are changing anything in the node, this is not the runtime. So it means that all the nodes need to update something. If you are just changing the runtime, then yes, off-chain workers are updated as well. If you think about what if I expose some additional RPC in my node, and then that RPC is only valid if a particular version of off-chain worker is running, that's possible as well. So this is why we have runtime API interfaces and the versioning of those interfaces. And then you can detect, oh, like this runtime does not support my RPC yet. So it means that I'm going to return some null values. But then if you upgrade the runtime, then all the nodes will magically have that feature. Is that what you have asked?
Yeah. OK. So, how to update? How to deal with it? What is the stack of steps that I need to do? Like, for example, I upload in my new runtime, right? And then in, for example, 1,000 blocks, it will go live. And I should update half of my nodes like already, or when?
No, so if you write your RPC code in the right way, that checks if the runtime supports a particular feature, then you can upgrade the nodes before you actually propose the runtime. And when the runtime is included, when the vote is passed, when the set code instruction is set, then they will have that feature available. So usually you have to upgrade nodes first, and then you get this additional feature. But the thing is that if you don't upgrade the nodes first and you upgrade the runtime, like the Substrate guarantee is, it's not going to break. The old nodes will just be running WASM and will not have this new feature that you implemented in the node. Does that make sense?
Yeah. Okay.
Thank you for the presentation. So I guess a similar question I had before about determinism. So with this example of BTC price, what if I have this logic like sell when the price is over 8K and buy when the price is like below 6K, which is like totally different routes. And then one node calls the BTC price and it's above 8K, and another node calls it like 2 minutes later and it's below due to volatility.
Yeah.
How do you handle that?
So as I said, the fact that off-chain workers are non-deterministic and they may have different results, that doesn't affect block imports. So this is run completely separate from regular block imports. And those workers can check the BTC price, but they can't really do any alterations on the state. The only way to change the state, change the on-chain data, is to create a transaction that will submit those results back. So then if you have multiple nodes feeding this BTC price, it might be different, obviously, but you can write a code in your module that handles different transactions that feed this BTC price and have some logic how to compute the real price or the actual on-chain price. And that's something that is really non-trivial. Like obviously you can just take an average of the results, but there is no way to verify that on-chain. So probably you need some more sophisticated game where you reward nodes that provide the correct data that is closer to the expected result. Maybe they need to be staked. Maybe you only want to allow that from the validators. So then your kind of trust model is, yeah, I trust my validators to run the correct off-chain workers because they are staked, because we can use the governance mechanism to kind of punish them if they don't do that. Or if you want to like open it up for every user to submit this price, then yeah, you need this like more sophisticated scheme how to resolve those conflicts. There's one more up there.
Hey, it's Alan from Substrate. We are doing off-chain computations in Intel SGX enclaves, as you already know. Mm-hmm. What I'm wondering is if what you did could actually be the base of what we are doing, but so far I can't see how you can really get out of WASM, because the code that you just showed is part of how the runtime module is declared. Mm-hmm. So is it already today possible to have a native off-chain worker but still have your module in WASM? Is that already possible?
Yes. So every module that you see is compiled both to native and to WASM. And if there is this logic that checks, if the runtime version is the one that I have natively, then I'm going to use the native version.
Yes.
So if you are running an up-to-date node, then it means that your code will run native. If you are outdated with the runtime, then you have to like fall back to WASM.
Yes, but I need to use libraries which support no standard environment. Mm-hmm. And so this way I cannot call my enclaves.
Yeah, so I was talking about everything that happens off-chain, so not during this block imports. And yes, whatever happens during block import, so any block processing, that has to support both native and WebAssembly, because otherwise you will get consensus issues.
So we would have to do like a host call for that, I guess.
Yes, but you can also use off-chain workers if you can do stuff not during block processing, but if you can offload this to this kind of off-chain application scheme. Okay. If you can imagine your work being done as an off-chain application, it can be done as an off-chain worker as well.
Thank you.
Hey, thank you for your presentation. I'm not sure to understand the application developer workflow, and specifically, who is allowed to update the runtime, and finally, what is the governance behind the acceptance of this new runtime version?
Mm-hmm. So that's part of your governance of your chain. If you're including the default governance scheme that we have in Frame, then it's going to be the council, the public vote, the democracy module, and so on. This is how you can update the runtime pretty much. But if you have your custom chain, you can have any governance logic. The thing is that off-chain workers are just part of the runtime, so they are updated at the same time. If it's not enough, then please come to the workshop and I can elaborate on this.
Cool. I think that's it.
Cool. Yeah. Thank you.
Thank you so much, Tomek.